Hey there, spacers. Welcome back to another episode of the Space Revolution. My name is Rick Tumlinson, and you are listening to iRock Space Radio. We're part of the iHeartRadio network and proud to be so. Hey, tonight we have a great guest. I'm so excited. Greg Chamitoff is a real astronaut and has flown in space twice. He did a long duration mission on the space station, and he also flew on the last flight of the Space Shuttle Endeavour. He was born in Canada and is now an American citizen. I was joking with him that some of our best citizens seem to come from Canada or Australia, or I'd like to say Texas. But it's great that Greg was able to give us some time, and we're going to be talking about. At first, we're going to talk about his newest entrepreneurial project, which is really exciting. It's called Space Teams, and it's a virtual reality system that, well, you know what? I'm just going to ask Greg, and he's going to fill us in all about it. Hey, Greg, thanks for coming on board.
Hey, happy to be here.
So tell us, let's start with that. Then we'll go back and talk about that, that boring astronaut I flew in space stuff. Let's start with your project. It's really exciting. So Space Teams, what is it?
Space Teams is there's a commercial version and a sort of a STEM version, but it's basically the idea was to make it possible for anybody to collaborate in the development of humanity's future in space. I suppose the fundamental idea is, about 8 years ago, I saw my kids playing Minecraft, and they were about 10, and they were collaborating online, creating amazing stuff. And I was like, why can't we do this for space? Why can't we do this to bring people together to make it possible for, to do all the things we want to do in space? And so actually the original name for it was Spacecraft. and that's still the name we call it internally. So you may hear me say it that way by mistake. But we've been working on this for 8 years. Actually, when the whole idea came up, I reached out right away to Richard Garriott, who's a good friend of yours and mine. And he flew in space with me on my mission. He came up for a 9-day Soyuz flight. And I called him up and I said, because he's, been working in this world, his whole career. And I said, I have this idea. I think it's the most important thing that we've ever done. I've got to talk to you about it. And told him about it the next morning at a brunch, and been working on it ever since. So I have students working at Texas A&M on this. Now we had a space grant with NASA to develop this because NASA needs this for the future of mission control. They need to be able to jump in and see what's going on in a mission in real time and follow it in VR and be able to stop and start and analyze what's going on. So it's basically like a digital twin, a virtual reality version of what's going on in space. And it can be, what NASA's doing. It can be with maybe someday what the Space Force is doing, and it could be whatever you create. And so we have a STEM version of this where students around the world use it to build out, a concept in space, an end-to-end mission, and actually fly it. It actually works because we put all the physics and engineering into virtual reality. And so we teach kids about space, and we use it for real life projects. So that's kind of the big picture.
Okay, so let me get this right. So there's somebody, let's say, they're out working on the arm on the space station or something, right? And so there's the real photography of it, but I'm just going to guess that the real photography can't hit all the angles, right, of what's happening, whereas you've got a VR version that's one-to-one with what they're doing, but on your version, you could swing around to the other side. You can do all these different angles that they aren't going to be able to do out there. So it's basically expanding their ability to understand their own environment while they're operating.
That's right. Yeah, actually, maybe this is getting a little bit into the career side of things, but while I was at NASA, one of the things that I worked on for 10 years of my life was called bird's eye view, and it's still if you look at the mission control screen right now, you'll see it's on the main screen in mission control and a lot of the mission controls around the world, and it's on the space station. And this was basically a digital twin before there were digital twins. We never heard of the term, but that's really what it was. It was the space station and everything about it. Which way the sun is, which way satellites are, where are you flying over the ground right now, and you could use it to figure out which window to go to right now to take a picture of something as it was coming up. But Mission Control had it, so they had situational awareness of what's going on with the space station right now, and each discipline could use it to figure out things like, oh, gee, we just lost our communication dropped off. Why? It shouldn't. The satellite's in view. Oh no, you could look and see that there's a solar panel that came into and blocked, an antenna or something like that. So all the different disciplines could use it to, in real time, understand what's going on the space station, or take it offline and then look ahead and say, hey, in 2 days, we're doing a spacewalk. Is this box going to be hot or cold? Is it in the sun or in the shade, during that interval? So all the different disciplines could use it to kind of look ahead and simulate. So that's kind of like, that's ancient history now, but it's still being used in the control center. We need this for every mission going forward, right? For every, whether it's Gateway, whether it's the Artemis, whether it's on Mars, whether it's an artificial gravity habitat in the future. We need a model of this that we can use for planning, for training, for real-time monitoring, and also for problem solving. And so that's what it is. And it's come a really long way. But we also created a STEM version of this because it was a fantastic way to teach kids about space, and they can design and collaborate virtually, get in VR and experience what it's like to stand on Europa and look at Jupiter in the sky, or build something and then get inside and fly it, land a spacecraft on another planet. They can do all this virtually and be totally inspired. So that's what we've been doing lately, and that's really exciting.
So this is a business, right?
Yeah.
Your private business. How did you get that first money? What was that startup period like for you? I mean, how did you go from, hey, I'm an astronaut, I got a cool idea, to I have a company?
Yeah, so it's worked out really well. I mean, I'm a professor at Texas A&M University, and so all the development of this, all the modeling and the simulation and the tools we're using, Unreal Engine, 4 moving to 5, all that capability, all the coding that had to be done. This is all student built. I mean, so we were building this at Texas A&M, and at some point, Texas A&M says, "Hey, that thing you're building, we should be commercializing that." And so, we already had a consulting company and basically made an arrangement with A&M. So A&M owns this. Texas A&M University owns this. My company has a license with A&M to be the exclusive commercializer and also developer of future applications for it. So this is a very cool arrangement because, as we bring in, funding to do something, we can pay the students, and they get to be, working on something that has, commercial applications, and they're involved in STEM activities and running them and interacting with younger kids and inspiring them. Younger kids are respond better to students who are a few years older than them and think, hey, I could be that way. That's right in front of me. I could be like that person. I can talk to them about space and everything, but if they see somebody that they could be just a few years ahead, that actually is a great thing. So yeah, so they're all of my students are involved in the STEM activities and everything, and developing all of this. And it's kind of we end up supporting, the lab at the university through all our commercial endeavors.
Oh, that's great. So, yeah, it's kind of you hear a lot about this kind of thing, especially in like biomed and such from MIT.
Yeah,
Where they will spin off. I'm sure it's been happening, but you don't hear a lot about that from other universities like A&M. So now you've got the entity. Now you have your own staff. You have your own office staff, or do you basically leverage off of?
yeah. No, you know what? It's all virtual. In fact, during COVID, everybody was working virtually, and because it's software, that works very well. We can even have big test sessions virtually. But you know what? No, what tends to happen is these students. We've had students who came in as an undergraduate, worked for years in our lab. Became a super expert at some aspect of this, whether it's programming, whether it's C++ or Python or networking or AWS or whatever, and then continue as a grad student. Perhaps maybe even all the way to the PhD, and then we have to let them go eventually, right? They need to go out in the real world. And but then they keep working with us because they love the project, and so they keep working with us sort of as consultants afterwards. So kind of have a network of former students, who are also part of this now.
So you have a great product, you have a great team. How are you getting it out? How are you? Is it being commercially marketed? Is it just right now to NASA? Where's it going?
Yeah, so good question, and that's been really challenging. And we always thought from the beginning that the way this would get out would be through student competitions. Like we would make it possible for students to use this to, when NASA announces a competition, hey, design us a rover for the moon or whatever, or design us an oxygen generator for Mars or whatever. The students would be able to use this to create and demonstrate, their design in action. And so that kind of, I guess, started us on the Space Teams Academy, which was a student version for them to go design something and compete. And so we ended up creating that ourselves. Basically, we have the competition we created ourselves. We provide all the parts essentially virtually, and the students can design and assemble a spacecraft. So what happens in the student version, they design a spacecraft as a team collaboratively virtually. They can, you can fight over where things go virtually. Someone can put a part down and someone else takes it away and throws it off, and you can argue and design at the same time. And you could be anywhere in the world doing that with your team. And so, but the ship has to work. It has to really work. So there's kind of like an AI built in there that corrects you and tells you, hey, it looks great, but if you start your mission, you're going to run out of oxygen in about 14 minutes.
Yeah. Laws of physics.
Right. So you fix the oxygen problem, and then that's great, but you're going to run out of water in 35.24 days or whatever. So you keep fixing the problems, until your ship works and actually can get you to the destination. And then they actually learn orbital mechanics. We have it; it's all graphical. It's like just like in the movies, you see like a holographic table, with showing trajectories and things. They don't need to know the math to understand. Orbital mechanics is something I teach at the senior level at the university, but kids can do it. I have, sixth graders doing orbital mechanics because we've built a whole graphical capability. You basically stretch the orbits and make them go where you want them to go. Math happens in the background, and they figure out how to make their trajectories get to where they want to go. Then they land their spacecraft, they build a habitat on the surface, and then they figure out how to sustain it. And so the ultimate goal for the students in this Space Teams Academy is, can you get to this other world, build a habitat, and be sustainable indefinitely? And if you can do that, that's like the ultimate score, right? Is to be, how sustainable can you get enough stuff there, as well as supplies, and then use local resources to augment those supplies to stay indefinitely. So that's kind of the competition. But anyway, trying to get back to your question, because we were trying to figure out how to get it out there, and that is one way, is through student competitions. But and thankfully NASA's helped us initially with a Space Act agreement to develop this for NASA purposes. But now we have a NASA grant for the STEM activity. So finally NASA's behind it in a real way. And so this grant is aiming to reach 10,000 students in schools over the next couple of years. So on the STEM side, we have a NASA grant now, and now we're trying to get NASA funding on the technical side. And we've been working with them, but we're on the edge of having that technical support to actually build something directly for NASA. So we'll see.
Wow.
Yeah.
Yeah. I've got a lot of ideas and questions I want to hit you with, but we have to take a break right now.
Sure.
You are listening to the Space Revolution. My name is Rick Tumlinson. We are on iRock Space Radio, part of the iHeartRadio family, and we have the amazing Greg Chamitoff, astronaut and entrepreneur, as our guest here today. We'll be right back. Hey there, spacers. We're going to continue our wonderful conversation with astronaut Greg Chamitoff and CEO of Space Teams. You are listening to iRock Space Radio, part of the iHeartRadio network, and this is the Space Revolution. So, Greg, you were talking before the break about this idea that these students who are using Space Teams are able to create and project a, let's call it, reality based scenario
Mhm.
for being able to go to planet X, the moon, let's say, establish their community or whatever it is they're building there. And then based on the AI feedback loops and all the data that's already existent, um, they can actually create a plan for a sustainable, permanent community, right? And based on real physics, real data input, providing supply chains and survival and all that stuff. Have any of the A, NASA Artemis, B, SpaceX, C, Blue Origin, any of these people, or Axiom, who are building space stations? It would seem that what you're talking about here could be applied to each one of the programs that they're looking at. Let's say, of
Yeah.
course, Elon's the big fish going to Mars, right? I don't know if a fish would survive on Mars, but anyway, he's the big guy. He's going to Mars, and you could sit down with a team, let's say at SpaceX, and say, okay, we're going to do 100 people. Here's all the parameters, the inputs, all of that, and here's how you create a supply chain to take care of them for the next 100 years. Is that projectable from your software?
Yeah, sort of. I mean, from the student perspective, what they're doing so far is it's a particular mission, and but we have kind of the next version coming out. And the next version is the one that will allow you to sort of go anywhere and build anything. You know, in other words, the version the STEM version, STEM. You know, let's call
Okay.
it the game. Let's call that a game. That version, we put the parts and everything in there that you have that you get to choose from in essence. But the professional version, you can put anything in, right? You can design anything. Could be any spacecraft, any system. It could be an oxygen generator. It could be a spacesuit. Could be a habitat, a rover, anything, any part of any of those things. Could be the actual design, right? And you can import that into the platform. So the platform is designed to integrate all the hardware and software and the algorithms. So if it's a robot and it has a brain, right, it has an algorithms for how it would react to a situation, its behaviors. That also can be connected, sort of like a plugin. So you really literally could put anything in there that you are designing or someone designed, to build an integrated mission. And then, simulate literally any mission anywhere in the solar system. So, we don't have, the internal workings of the Starship in there, but we have the Starship in there, and we are landing it on the moon, on the South Pole already in our simulation. And we are building, we have students building other lander designs. So we actually have control of designing the cockpit and the controls. And so you can, fly it automatically and then jump in, take over and land it. But you're in VR and you're really doing it. You're looking out the window. You're seeing what the moon actually looks like, with perfect lighting, and everything's exactly how you will actually see it when you get there. So yeah, the idea is you could literally simulate any mission, anywhere in
So
the
right
solar.
now, you're kind of, you have a boundary because you want all the students to be sort of, I don't want to say, well, you said game, by the way, and you know I would use that word when talking to students. It's a game,
Yeah,
and so there are boundaries within the game that
right,
say you're doing X, Y, Z, and who can do it better or best, or what is your
right,
best,
right.
right? Okay, and then you can take all of those parameters, put them into your AI, your system that you have, and then it opens up to anywhere you want to go, anything you want to do, basically.
Yeah, right. So the commercial version of this is, build anything, go anywhere. Right?
Right.
Collaborate with anybody, share models, don't share them publicly, share them publicly. Um, and, I mean, ultimately, what we would really like to do, we've built a ton of models. I mean, not just, models of spacecraft and rovers and robots, but also radiation models and atmospheric models and gravity models and surface models, right? So excavation models, so you can go and actually excavate on a surface. So we've done a lot of modeling. But ultimately, what we want is the user base to build all those models, right? So, like, we want the user base to share models, like create. Someone can create. An example I like is, we don't have a GPS system for the whole solar system, right?
Right.
But we can imagine one. And if someone built one and designed one and could share it, on this, we call it, like, the space team's metaverse. You can share your GPS design, and then someone else can use it to figure out how to navigate to, wherever they're trying to go, Phobos or whatever. And when they can't navigate on the backside of Phobo, they can complain about the GPS system not having a hole, having a gap, and then someone else can fill the gap and make the GPS for the solar system better. So this kind of collaboration that we really would like to see ultimately.
Yeah, it's interesting because you're basically building a virtual solar system,
Yeah.
right? And all the human interactions with that solar system. And by the way, you mentioned GPS. One of the companies we've invested in is going beyond GPS now, right? And they've come up with some stellar navigation stuff for when you are out of GPS range. They're called
Mm-hmm.
RIA, and they're getting a lot of traction too. So that could be fed in. It doesn't really
Yeah.
matter. All of these different navigational things. But again, I am fascinated by the idea. Something I've been talking about a lot lately is that, let's say we're, Starship happens, or New Glenn, one of them, a reusable, what I'm calling an RSST, reusable rocket ship technology
Mm-hmm.
happens, right? Which is really going to open the solar system, right? And I believe shortly thereafter, some group is going to show up at one of these companies and say, okay, we need an initial flight of 50 people and 10 years of resupply. And here's everything we need to land there, pre-position. And here are all the variables we're going to have to answer. And then they're going to have to sit down and write out a contract, right? And it's like the new pilgrims, let's call it. So what your software would allow these people to do is have a realistic projection
Yeah.
of all of those needs, right? And then they can sit down and go out in the markets and say, okay, this is going to cost this, and then on the SpaceX or Blue Origin or whoever side, they can say, yep, here's what we have to charge you. And now, and I'll wrap up with this, is that then that group can go out and say, okay, we've got to raise this much money, for over a 10-year period to
Mm-hmm.
supply our first 50 people at our community, our colony, or whatever it is, our monastery, whatever it is that they're going to build. And that's amazing. That's some amazing stuff. Not only that,
Yeah.
you are exciting an entire generation who's coming up using the software, who's going to have a
That's what we're
level of
hoping.
expertise, right?
Yeah. Yeah.
Yeah.
Yeah, and the idea is, it's not just the design. Because it's a VR, it's an experience. You're actually running the mission. You run the end-to-end mission, or you create scenarios like, here's what we expect to be doing when we get there, right? And look at that scenario and analyze it and say, well, what if we added a robot? What if we didn't go as far away from the habitat? What if
Yeah.
we wanted to bring this extra tool? How would that affect the mission? And you can explore all that before you build anything, buy anything, fly anything.
Mm-hmm.
Right. And so you have it all figured out. You've been there, you've done it, to the greatest extent you can. You've really looked at the whole mission and everything you need and what you want to do, and optimized it already. And did it collaboratively. That's really
That's the key, because each one of these, and people, a lot of our listeners I know understand this, some may not. Every tiny little aspect of construction, life support, transportation, everything in space is its own field of expertise and gets down to super micro levels. So, for example, um, the air in the habitat, right? And at some point, you're going to, like, maybe you've got paint on the inside of the habitat and it's releasing a gas, and eventually that gas is going to kill you. So, what you're saying, because this is going to be crowd built over time,
Mhm.
is that there are probably people out there that have that expertise,
Mm-hmm.
and they'll put that data in. And so it's just going to get smarter and smarter. And so
Right.
somebody builds a space hotel, and based on this data, it goes like, in 10 years, you're going to have this gas problem and you need to fix it.
Yeah.
So it really becomes a tool for both business, government, and fun.
Yeah, no, that's a good example. Like, for example, lunar dust is there's
Oh,
some, a lot of people working on lunar dust, very complex models, being able to plug in a model like that, to this is, we can make the, a model, that's not as optimal as what the experts are doing, right? But we can plug in the experts model. You mentioned like a paint, basically diffusion of a gas. So when within our models, within space teams, when you take parts and you stick them together and make a habitat or a spacecraft or whatever, all those modules have got um, they have devices, right, that are making resources, storing resources, using resources, whether it's power or data or oxygen or water or whatever. And so the connection between all the modules allows us to do basically resource flow. So this is all being modeled already. In other words, when you have a habitat there, let me give you an example. If a hatch is closed and you have a certain amount of a concentration of a gas on one side of that hatch, it won't diffuse to the other side. But if you open the hatch, it will. And it's already keeping track of that kind of thing. You would have to probably put in a model for the paint chemical you're talking about. But
yeah, but
yeah,
somebody will.
yeah,
Somebody will, right?
somebody will,
Right,
right, right. And they'll
right.
put in a better radiation model that accounts for propagation through the shell of that material structure, on the outside of that spacecraft or habitat or whatever.
Yeah,
Um,
secondary radiation. So yeah, it's interesting too. Again, I talk a lot about the frontier, and we're going out, and all of this, and um, the fact that your product, your plan here is to create something that will basically, at an ever more microscopic level, predict what's going to happen when you get there.
yeah,
It's going to save a lot of lives. It's going to save a lot of money. It's just going to make it so much. People don't realize, for example, when the ships used to set sail back in the day of the age of exploration, they used to overstaff the ships by like 1/3 because they expected 1/3 of the people to die. Right? That's they
yeah,
they had a different sense of human life back then than we do now, but we do have that sense of the preciousness of life now. So what you're saying here is that we can't predict everything. We'll never be able to predict everything, right? But we can certainly use your software to create as much of a predictable environment as possible that humans are going to be living and operating in before the first piece is manufactured, before the first, anything is done. You'll have an idea of where we're going and what it's going to be like. And the beauty of what I really excites me about this, Greg, is you're starting with kids and gaming.
yeah.
And yet it's like a very, very serious thing you're talking about.
Yeah, I think the idea that it's what we do at conferences, right? We come with all these great ideas and we share them and talk about them, but we walk away from the conference and everybody's still working on their own thing and they're not connected to each other. So this, the dream here is this is a way to connect all those ideas, put them together in the same universe, and actually build it out, together, collaborate, and you can still retain your own ideas and IP by but be able to actually put things together. And if you're trying to figure out how to land your spacecraft on Mars, you're not an expert at modeling the surface of Mars. So it's fantastic if you could use a tool that already has all that in there, has the atmosphere and has
Right.
the Mars surface in there. You work on your spacecraft and then in the landing system. And so having these shared the shared space where we can collaborate like that is really amazing. But from the student perspective, just the very basic thing, like exactly what you said, like the very basic thing is the solar system, right? And so like if you created a simulation with space teams from scratch and you didn't add anything, what you would have is the solar system.
Mm-hmm.
And then you could fly around and check it out. So like this was like the thing I've been waiting for, as we've been building it the whole time. I just want to stand on Europa and look in the sky and see Jupiter. I want to stand on Titan. I just want, or be closer to Saturn and see it and see what it really looks like. And we can do that now. And right now, what's really important is standing on the edge of Shackleton Crater, and seeing what the lighting is really like and what it's really like going to be to work in that environment. And so that I think is something that is really, it could be inspirational for the next generation, for the kids, because they can't visualize, without something like that, what it's really like to be in that environment. And as soon as they see it, I think it just, wow, that's really there. I want to go. I want to make this possible.
That's exciting. That is so exciting. By the way, Shackleton is one of the craters on the south pole of the moon that everybody's trying to get to because we believe there may be ice at the bottom of it. But speaking of the bottom of it, we are at the bottom of this section. We're going to come right back in a couple of minutes with our astronaut, with our guest, astronaut Greg Chamitoff. You are listening to iRock Space Radio, part of the iHeartRadio network. My name is Rick Tumlinson, and you are tuned into the Space Revolution. We'll be right back. Hey there, Spacers. Welcome back to the Space Revolution. I am your host, Rick Tumlinson. Our guest is astronaut Greg Chamitoff. So, Greg, we've been talking about your Space Teams project, which is just amazing. And as I was telling you, we went through the break, it's blowing my mind. There's so many possibilities in terms of what we can really do out there. But speaking of really being out there, you are an astronaut, and you've been out there twice. How long were you on the station doing that longer?
Almost 200 days altogether.
200 days. Just a little about that. What was that like?
Well, I can tell you this: the Earth is not flat.
Okay. Well, we just lost half our listeners. No, I'm kidding. Our listeners are actually intelligent people.
Yes, I know.
Okay, good.
Yeah. I don't know why I thought about that, but it really cracks me up.
Yeah. There are people out there that have that issue. That's a whole nother conversation. But
yeah. Go ahead. Well, I think that the better answer is seeing it with your own eyes, seeing the Earth with your own eyes is really, really something, really amazing. I mean, because we know a lot. We've seen it in pictures, we've seen it in movies, and we know what the Earth is. But when you see it as one object, from a not that far away, we're pretty close on the space station, but just to see it as a whole thing, with your own eyes. Just floating in space and being able to look, the Earth is over there and over here is nothing. It's just unbelievable. It's just
yeah. And it's funny because we've just spent the first half of the show talking about simulations, right? Yeah. But nothing, from what I understand from all the astronauts, cosmonauts, private NASA that I've spoken to, nothing compares in any way, whether even the best possible simulation, with actually seeing it from out there, right?
Yeah, well, and it's different every time you look at it. Just the different lighting conditions, different weather conditions, different lighting on different parts of the Earth. Different times of the orbit, and the space station orbit. The fact that it's a really high inclination means you get to see a lot of the planet, and the orbit. The orbit doesn't stay fixed, in inertial space. With respect to the stars, because the Earth is not a sphere, there's a torque on that orbit, and it's always shifting, about 6 or 7 degrees per day. So, over the course of almost 2 months, you get to see every part of the Earth under different lighting conditions. So sometimes you're flying over Canada in the daytime, and, and you don't see South America, and then, a few weeks later, you see South America in the daytime and you don't see Canada, in the daytime. And so, you get sun glint off of different lakes and things that, during parts of that cycle, and get to see the shoreline of Antarctica during parts of that cycle. And so it's incredible. I had that cycle. I had 3 of those full cycles of, all lighting possibilities over the whole planet. Because I had about, it was 183 days the first time. So it was like 3 of those cycles. And it's very beautiful. It's really hard not to take a picture of everything. Every time you go to the window, you're just like, wow, and you're taking pictures, but you want to also just soak it in and try to capture it, in your soul and not let it go. I tried one time to like go a whole orbit looking out the window without taking any pictures. And I saw the most incredible things during that orbit. It was killing me, not to take pictures. So.
Yeah, but I'm sure there's a Japanese saying about this or something, but there is one permanent camera, and that's your mind. And
Yeah.
we are in this age where we take pictures of everything, everything, everything.
Yeah.
A lot of times, you actually lose the contact with the actual thing you're looking at because you're so busy taking pictures for later.
Yeah.
But you'll always have those memories, and they've
Yeah.
reached your soul, right? They've transformed who you are.
Yeah.
Right? Is that something real? My friend Frank White wrote the overview effect after
Yeah.
interviewing a lot of astronauts and cosmonauts. His assertion is that there is something that shifts in people who go into space. Do you agree with that?
Yeah. I mean, I think, yeah, I don't know. It is a profound shift, I guess, but it's, I don't know if it's easy to put into words, but I think it's just an appreciation, for, the way I like to put it is that, you know, the earth is, we're part of the earth, we're a product of the earth, but we're very special. We may feel very small, especially when you're looking at something that big, but we're a very special part of the earth. We're a part that can appreciate what it is. We're the only part that can appreciate what it is. And so to be out there and looking back at the earth, even though we're so small, we're the only part that can actually look at it and wonder, we're like, well, why is it the way it is? And really appreciate that. So that's, and then you don't feel as quite as small, because no other part of the earth can really do that.
Right, right.
Yeah.
One of the assertions in our nonprofit, the Earthlight Foundation, that I have is that um, the third principle we have, which is to explore and experience the universe. The assertion we make is that we are the mechanism, and any other sentient beings, in some other world out there,
Yeah.
that by looking at, experiencing, touching, interacting with the universe, we make it alive.
Yeah.
By our own perception and interaction. And
Yeah.
you're talking about how hard it is to describe. I've had the same conversation, like with the mother of my daughter, my beautiful daughter Alice. How do you describe the first time you look down at your child that's just been born, right?
Yeah.
And she basically said the same things you just said, right? Except in this case, it's the child looking back at the mother.
Right.
Us as
Right.
human beings, right?
Right. Right.
She's like, well, I can't describe it. There's just a thing going, this connection, and da da da.
Yeah.
And I think hearing your voice just now, that's
Yeah.
kind of where you are, right? It's that kind of feeling, this connectedness.
Yeah. It's connected. So you can't. It's you may be able to leave the earth, but you're everything around you that you brought with you that's keeping you alive is dependent on the earth, and so the string is never never really cut. So yeah, no, that's exactly right. It's like the child looking at the mother. That's a perfect analogy.
Oh, great, great. Well, so and by the way, that means that same sort of wonder you were just talking before the break about simulation of being on, what was it, Europa? I think you said, or was it Europa?
Anywhere, but yeah.
I guess in Europa you'd be wearing snowshoes or something. But,
Right.
but you're out there and looking at it. These are the kind of sense of wonder that we're all going to be able to experience as we break out. And
yeah.
But then there's the real side of it. Like, you're living in a little box, a little tube. How many people are on there with you?
Most of the time, three of them.
Okay.
3 total,
so,
usually. Yeah.
What's that like? What is it like to hang out with 3 of your new best friends?
Okay, so a couple of thoughts that that connect directly to what you said. So here's a first thing. When you envision your whole life wanting to do that, and then finally you arrive right at this, in this case, the space station. You kind of never pictured in all your years leading up to that when you got there, it was your best friends letting you But that's actually what happens because you've been with these people training for years now, and so when you get there, it's your family, it's for people you've been living with, and well, in this case, in Russia and Japan and the U.S. and Canada, it's people you've been with for years. That's who opens the door and lets you in. So so they're not new friends. They're already your best friends. So that's one thing that's pretty neat. The other thing is, when I was there, okay, I was lucky in that up until the time I was there, and I think forever after the time, not forever after, but after that time, up until now, and probably for some time in the future, the space station, we had the most hardware in space ever, because space station was almost complete. Million pounds of hardware, for the space station, the standard thing is it's the size of a football field, but it's really bigger because it's a football field in two different directions. You couldn't lay it down in a football field. You would need two football fields to lay it on the ground. It's really massive, complex. And then with the shuttle attached to it, I came up on a shuttle and went down on a shuttle. So, even though I trained in Russia, I didn't know which vehicle I was going to go up and down onto until the last 2 months before flight. But with the shuttle up there, another 250,000 pounds, it was the most stuff in space ever. And then the shuttle stopped flying, soon after my last flight. So, so it's going to be a while before we have that much stuff and, attached, in one place. It'll happen, but it's going to take a little while before we get to that size. So there were 3 people up there, with all that space. And I was for most of my flight, I was the U.S. crew member, and there were 2 Russians, and they pretty much stayed on their own side. I would go down there and have meals with them, and they would come up and ask me if they could use an exercise bike once in a while. But I did everything on the U.S., Japanese, European side of the space station, and they were working on the Russian side of the space station. And so actually, when I was up there, most of my time I was alone on a half of a space station. So I was glad to, when they came and said, "Hey, it's lunchtime, let's go." I had some camaraderie, but my camaraderie was around meal times and then evenings when we would, on a Friday night or something, we'd watch a movie together. But it's a big space station, it's not a small space. It's if you had to find somebody and they were not along the main corridor, you might have to search for 5 minutes to find them.
Wow.
So
yeah, you don't get that feeling.
Yeah.
Wow. Okay. And you and your Russian compatriots got along?
Yeah, very well. Yeah. I mean, it's really sad what's going on now. I mean, it's sad for so many reasons, but the space station was really a flagship of international cooperation, and so much went into that, and it's still going on. I mean, I find it even hard to believe, but right now, I mean, still working with the Russians, 100%. I mean, we can't operate the space station independently. They can, and we can't. And so that communication and interaction is going on 100. I mean, at the level of, the space program, it's 100%. We're all friends and working together, and that hasn't changed. But I find it even hard to believe now that people are traveling back and forth to train. I wouldn't want to be in Russia training right now. I would feel I'm at constant risk of, being abducted.
Right.
Yeah.
Right.
I just can't. It's really, really a shame because, we really spent, 30 years developing this international collaboration and built something amazing that was for the purpose of world peace and cooperation. And at least, with Russia, it's just being destroyed. I mean, that's never going to happen again.
Well, hopefully, I wouldn't say never again, but I think that we'll learn from it and, hopefully move on, depending on what happens on the Russian government side of the world.
Yeah.
When we were doing the Mirror project way back in the day, and our Russian team members and such, they were great. We had great collaboration. When I'm doing my talks, I'll be doing one this afternoon to a bunch of kids, and I'm going to point out that there's one place in the solar system where Americans and Russians don't just live and work together; they actually care about and at the level of friends love each other.
Yeah.
And it's a couple hundred miles up right there.
Yeah.
Right.
Yeah.
And that's an example for all of us to be able to follow. So that's
Yeah.
cool.
Hopefully it can continue to be an example. Hopefully. Yeah.
Yeah. Well, look, we're going to wrap it up this section. We'll be back in a minute. Okay, Spacers, talking to Greg Chamitoff, astronaut extraordinaire, entrepreneur, and coming into our last section here, we have some very important questions for Greg. Very, very serious stuff. Coming right back. You're listening to iRock Space Radio, part of the iHeartRadio network. The space revolution continues. Hey, Spacers, coming into the last quarter of the hour here for the Space Revolution. I've got Greg Chamitoff, Canadian-American astronaut and entrepreneur. We've been having a fascinating conversation about both his project, which is the VR Space Teams project, and actually being an astronaut, what it's like to go into space. And so we're going to ask our traditional fun little questions here. Actually, that's very serious, Greg. So you're flying in space. You're transiting the moon. Thousands of clicks an hour, and you can where you can actually feel the speed. Looking out your window, what music would you be listening to?
Oh boy. The music was a big thing on the missions. That's true. And I watch my own mission videos, and "A Beautiful Day" by YouTube. That one keeps inspiring me over and over again.
Great. I love that. Now I have to ask this question. You guys have to use like AirPods and headphones, right? Because otherwise somebody's going to be like, I hate that country music you got going down there, man. You got to turn that off, right? I mean, or do you ever have a moment where you just flood the station with sound?
No, there's enough noise up there that if you want to listen to music, you probably need a headset. Yeah.
Oh, okay. It just never occurred to me before. Like, hey, turn that up. All right. What was there a piece of literature, science fiction or science, that inspired you to get into this field?
So there's probably two things I'd bring up. One is I loved Asimov, and I am reading it all over again right now. Probably because the Foundation series started on Apple, and that was amazing. And I said, okay, I need to relearn the story and catch up. So I'm ready for the next episode, next season. The whole Foundation series and the Robot series, and I was very inspired by that when I was a kid. But Star Trek, this is video, not books, but that was really what I kind of grew up on Star Trek. But something happened at the beginning of my flight. We were allowed to bring 5 books up to the space station, and I had picked out some books, and then Arthur C. Clarke passed away like just before my flight. And I swapped out all my books for his, and I can't remember if I already had one, maybe not, because I already read I brought ones that I read before, so 2001, 2010, 3001, several others, and then like a big book of short stories, and so I brought up all Arthur C. Clarke, and kind of had a tribute to Arthur C. Clarke during my mission. So,
like hit my strings. You can't see it on the podcast, but behind me is my poster signed by Uncle Arthur. And he was actually a friend. And,
wow.
I threw a birthday party for him in Hollywood in 2001.
Wow.
And he showed up in VR. But I got to know him down in Sri Lanka. An amazing gentleman, and a massively intense ping pong player, by the way. There were 3 of us there. He kicked our ass, all 3 of our asses in a row. Boom, right? But anyway, these guys, set up a vision of the future that's just so exciting. And you've just inspired me. I'm going to go get the Foundation trilogy. I was also honored to have met Isaac. He knew about the Space Frontier Foundation, which we called the foundation, and he thought that was so
Right.
funny. He thought that was funny.
That's cool. Yeah.
He had a wicked sense of humor, that guy. But anyway, I feel you on that, And what was it though that clicked you into I'm going to be an astronaut? What did that?
Well, okay. So that, I grew up in Montreal. The Apollo program was underway when I was a kid, and my father was just blown away. He was an engineer, and we were watching mission control and the rocket launches, and he was just blown away by how lucky those people were to have that job. He couldn't understand, how do you get a job in mission control? Who are those people? And Star Trek was happening at the same time, right? And I was only 5 or basically at that time. And but there was one interesting thing, was that Captain Kirk, William Shatner, went to the same high school as my father. And at 5 years old, I understood that this guy I was watching gallivanting around the galaxy went to school with my father. And I think, how do you separate reality from fiction at that age? It just seemed all possible, well, here's this guy doing all this amazing stuff that looks really cool. I want to do that. And my father knows the guy, it was really, and then we went to see a launch. It was the launch of Apollo 11. We didn't go down there for the launch. We went to Florida for a vacation. And I was 6 at the time, and got to see Apollo 11 launch. And that was it. I told my parents that that's what I wanted to do, and somehow managed to hold on to that for a very long time. I got to call William Shatner from the space station, actually, and it turns out I'm the very first person to call him from outer space. And
really,
yeah, and I didn't, and it was just the strangest thing to talk to Captain Kirk, and I was the one in space, not him. It just didn't make sense. And but that was,
now he's gone.
I know.
And I actually saw him last week for about 4 minutes. And I spent 3 of those minutes trying to remind him that in 2000 I had told him all this cool stuff was going to happen. And but he is such a gentleman, such a visionary kind of guy. I had always thought, well, not always, but for so many years, I thought he was like this ham actor or whatever. But when I watched him get out of the Blue Origin capsule and crying and talking about the Earth, such a real thing. And the fact that he inspired you, and then you were able to reach back from up there, that's cool. That's poetry. That's definitely poetry, right?
Yeah, it's very lucky, because we basically, when you're up there for long enough, NASA gives the opportunity to choose a few events yourself. Like they don't, they got to choose which schools or events they're going to have you do appearances at, given a limited amount of time from orbit to do that kind of thing. But you get to choose one a month when you're up there on the space station. So, and of course, most of the time I chose a school of kids. And spoke to as many kids as I could. But one of my events was for me, and that was it. So.
That's incredible. Yeah. So we're going to be kind of running into the end of the show here, but we have a wide range of people that are listening, but some of them are younger. Actually, when we finish this, I'm going to go talk to a bunch of like 14-year-olds, which terrifies me because they are completely unfiltered, and they are going to hold me to account to everything I say to them on stage. But at the same point, by the same token, people like you and I, our job is to inspire them and to show them the path. Unfortunately, most of them are not going to have a major TV star who portrays a space captain who went to school with their dad. They're going to need somebody, which is really
something
cool.
else, hopefully.
But that's really cool. That's really cool. So, and we'll do this in 2 parts. How do you feel about the future of what's happening in space right now? Just at the big picture.
I think it's really ramping up again. I think there was a time, I think, because I was at NASA and the shuttle program retired, and there was a real sense of things slowing down. I mean, there was a huge difference in pace between how things were going. When I started in the astronaut office, when we were flying shuttles were flying 5 to 7 times a year, with 6 or 7 people on them. That's like 50 people a year going into space. A lot of different countries were participating with us. And then this, building the space station, and we were ramping up the number of crew on board. But once the shuttle stopped flying, missions are 6 months long, and if there was 3 people on board, it's only 6 people a year flying. This is a very different pace. And the astronaut office went from 142 people down to less than half of that, in that time period. But things are really picking up now. I mean, with Artemis, we're about to go back to the moon for real. It's really exciting. That took a while to get around to that. But I left NASA at a time when we were really getting started on that, and now it's really happening. So that's really exciting, and I think that's the beginning of a big push out. I know there was a time when we first put the space station up, and I felt like it was a. I think I've heard you mention this too. I don't know how many people noticed, but in the year 2000, the first crew went up to the space station, and that was the first moment where we became a permanent spacefaring species. As long as we kept the space station flying and didn't have to abandon it, and hopefully the next thing comes along, and there's other space stations and moon bases and other things coming. That was the transition. So happened to be exactly the year 2000. When we made that transition. And so I feel now very reassured that now there's the Chinese space station is there, and we're going to the moon, and I think that really will be the time, the year 2000, that we made that transition to always having people in space, and then that number just growing and growing and growing. So I'm really looking forward to seeing, and I'm doing everything. All my projects and all my classes at the university are all about bases on the moon and exploration and robot teaming with humans. And, I think it's a very exciting time.
Yeah. And then hopefully this year, the gateway opens up, no pun intended, the railroad opens up, and the transportation systems that'll allow people to go. My old friend, Bill Gerstenmaier, at one point pointed out to me that, you've said you had largely, a lot of the time there were 3 people on the station. And he pointed out to me that it takes roughly 2.75 people just to keep the lights on, right? Which leaves a quarter of a person when you were up there, and or person time,
yeah,
to dream, to come up with new products, to come up with new ideas, all of that. And yet look at all the great things we've gotten.
Mm-hmm.
Now, if you project forward, and we're about to open the gates and let people go out there, it's going to be staggering, the stuff we come up with. It's going to be staggering because we're going to have thousands of human minds out there, the ones you're training, by the way, in VR. So the future is going to be amazing. So as we prepare for that, got a kid sitting out there who's listening, a young person somewhere in the world who's listening. Again, maybe they didn't have the relationship to Captain Kirk that you do. What do you tell them? What would you, or they're an entrepreneur who wants to get involved in space, whatever it is, what would you tell them about getting involved?
The thing that really struck me when I was on the space station was, there's a window in the 2 windows in the Japanese module that look out, to the sort of to the north, because the orbit's inclined, but basically looks to the north. And but they're beautiful windows, and the biggest windows you can look out of to see the whole Earth, and also it's a perspective where there's the Earth below and the sky above and the stars. When we come around the dark side, the back side of the Earth away from the sun, and you can actually see the stars in the sky. And but outside that window also there's a platform, a Japanese experiment platform, and the whole truss going out the port side with massive solar panels on it. And so I would spend a lot of time. In fact, I slept by that window a lot because I would go there, stare out. When it was time to go to bed, I'd just go stare out that window, and it'd be really hard to leave it. So sometimes I just put my sleeping bag by that window and fell asleep looking out the window. And the feeling that I had was, this isn't science fiction anymore. This isn't just a dream anymore. We are really there, and we're there in a big way. I mean, that space station is it's a big space station. And all we needed to do, would be to strap on some engines that had enough thrust, and that space station could, fly off to Mars, and it would work perfectly fine around Mars as well. It happens to not be able to get there, but if you could push it fast enough, it would go to Mars, and those solar panels would work at Mars too. You might have to turn a few experiments off. So we're there, we're there. And the other thing is, we adapt to space. I mean, it's incredible how we adapt. After 6 months on the space station, I couldn't remember what it was like to feel gravity, to sit in a chair like I'm sitting in right now. It's like, it's going to be really weird when I sit down again, and I feel pressure on the bottom of my feet. We adapt to that environment. It's a human experience to live and work in space. It's going to be a massive human experience that a lot of people are going to share. It's going to become normal. It became normal for me. After 6 months, I was perfectly happy. I could have stayed up there forever. Um, you know, it, and so I think for everybody who's, kind of dreaming of the future, it's not a sci-fi movie. It's for real, and you can go there, and we will, and you will.
That's perfect.
Yeah.
Thank you, Greg Chamitoff. That was it.
Yeah.
That was beautiful. I'm not even going to say anything else. That was beautiful. Thanks for showing up on the Space Revolution and being a part of that revolution. And Spacers, I just want to thank you for tuning in. We're taking this program to a new level. This is the first episode of this new level we're going for. We're going to raise our orbit, let's say. And you are listening to the Space Revolution on iRock Space Radio, part of the iHeartRadio network. We are heading out the airlock.